All right. Welcome everyone. Good afternoon. So this is a continuation session for the routing protocols. And then we started with definition of routing. We've discussed about static route and dynamic routing. So EIGRP is one of the most popular and widely used routing protocols in production. Most of the organizations, they make use of it. Another concept we should get familiar with is we have different shops. Different shops I mean is this. Most companies that use Cisco devices majorly. Cisco devices, majorly they call them Cisco shops. So EIGRP, any environment that predominantly Cisco devices, Cisco routers, we may find ourselves in that. If we find ourselves in that kind of environment, we need to get used to EIGRP. EIGRP is what? It's type of the dynamic routing protocols. It can be used side by side with other protocols. But one thing we just need to pay attention to now to get known at this level is we need to know that EIGRP is an open source. Before, it was majorly Cisco proprietary. Cisco proprietary means that it only works with Cisco devices, but now it has become an open source. What it means is that it can work with any vendor devices. EIGRP, if you remove the E, it is distant vector. But with the E enhanced, it becomes what? Hybrid. We have discussed all that before. I just want to make some emphasis on it. And then another thing we need to pay attention to is the administrative value, that is AD. When we are configuring it now, we show us where we can identify the AD. Having said that, these are the metrics. These are the metrics EIGRP uses to decide neighborship. These are the metrics EIGRP uses to decide neighborship, to form neighborship with connected routers. If two interfaces were configured to use EIGRP, the routers must fall into some of these metrics before they can form neighborship. And then I've touched base on that one before when I talked about AS, autonomous system. EIGRP uses AS like BGP. So what AS does is it categorizes some set of routers. It categorizes some set of routers into a group. It put them in a group. This is AS100. What it means is that if a particular router has different AS number, it will not be able to participate in particular EIGRP convergency, or it may not be able to form neighborship with the connected router. Like I said before, these are the metrics it uses to form neighborship: bandwidth, load, delay, reliability, and MTU. MTU is what? Maximum transmission unit. We need to pay attention to these metrics. Because of what? Just because of interview, they ask for it. And then they ask for attributive value as well. Every other things we can just know it and move on. And then, like I said here, EIGRP configuration is very straightforward. It is a two-step process. It is a two-step process. This is the step one. This is step two. It now depends on what? On how many routers we want to configure. And then here today, I will introduce us to widecast. What is the widecast? Widecast is what? Inverted subnet. You know, we have subnet as 255.0. But the widecast will now be the opposite. It will now become 0.0.0.255. So this is the calculation here. We don't need to know how they got the widecast. We just need to know what is widecast. Widecast is the inverted subnet. We got it by minusing the subnet mask from what? From the 32 bits. So what we minus it, and then the result will be our, it will become our widecast mask. Why we need to use widecast mask, I will tell us when we are configuring the EIGRP. So EIGRP uses AS number to create a group of routers that share routing information. You can choose any number from 1 to 65,355 as AS number. This is autonomous system. And then there's a note here. If two routers belong to different AS, you need to pay attention to this side. They will not share routing information. If two routers belong to different AS, they will not share router information. If we configure EIGRP 100 here, this interface, and then the other interface is AS 200. These two will not form neighborship. So what are the things we need to take home here? We need to know that EIGRP uses AS to form adjacency or to form neighborship with other routers. EIGRP uses AD number 90 as what? As the interior AD. EIGRP can be used on internet, that is external, but we don't want to go that route today. But let's pay attention to the default, which is 90. So when we go to the lab now, we see how it's being configured, and then some of the metrics it uses. There are some other things we need to know, but when we are configuring it, I will tell us like visible successor route, visible distance, and all that. But the most important thing we need to pay attention is that EIGRP uses these metrics to what? To decide forwarding decision. Any question? Okay, let's move on. So we understand what the white cast is all about, how we got it. This is how we got white cast. We minus, it may not be 255. If it is /27, the same thing applies. We need just to calculate what our subnet mass of /27 is, and then we'll minus it from the 32 bits. And then this is the formula to calculate EIGRP. This is the formula. We don't need to memorize it. With time, we'll get used to it. But what I've advised in the beginning is this. We should pay more attention to OSPF and BGP. These two is more predominant in the industry. These two routing protocols. Most organizations use it because they are what? They are open source. So today we're going to discuss and configure only EIGRP, and then it is advisable that we try it on our own to figure it out. And then if you have any challenges, I'm available to look at it together, and then we troubleshoot together. Okay, if there's no question, let's move on to the lab.
So my question is, if they are trying to throw questions on that, how is the question going to be asked? Maybe on that the metrics. Do they have?
Say that again, bro.
No, I say if they likely to ask questions on the metrics of the EIGRP, how is the question going to be asked?
Okay. Most of the time, when they want to ask about EIGRP, they may ask, what is the administrative value of EIGRP? And what are the metrics? Or immediately somebody asks us about EIGRP. One thing about interview is this. Interview is meant to do what? To test our capacity in two key areas. Number one, our understanding about the technology. Number two, our communication skill set. So if somebody asks about what is the AD value of EIGRP, for example, which is 90, is it enough to just say 90 and keep quiet and expect to get the job? Any Jack and Harry can say this one now. So the best formula is this. If somebody asks in an interview that, okay, what is EIGRP? Or what is administrative value of EIGRP? We start from what? Definition of EIGRP. We talk about it, we say, EIGRP is an enhanced interior gateway routing protocol, and then it's an hybrid dynamic routing protocol. When we have those two information, the guy will know that this guy knows what he's talking about.
Yeah.
And then he uses what? He's using AD value of 90. And then EIGRP uses some metrics like bandwidth, delay, and some other factors to decide or to forward packet to the destination. Or it uses some of the metrics that is common to hybrid routing protocol to make forwarding decision. Without even mentioning all this, the person, when we mention metrics, the guy will know that this guy know about metrics. But when we just say it's 90, it's not objective. So that's where we stop. So the next step will now come, can you tell me how to configure it? So when they ask how to configure it, that's where we come here. That's okay. The configuration is this. We now explain. And the another place they only ask is this. They only ask, oh, what are the commands to troubleshoot? So we may say like 1 or 2. It's not nobody expect anybody to memorize anything. But when you know something, immediately you are saying something about it, compare them with this and that. Somebody knows that this guy has overview about it. Does that make sense?
Yes.
Okay. Okay, let's go to the lab now, and then we test the concept, and then we need to try to practice on our own, please. There's no amount of time I will spend here that will make it grand in our minds without practicing it. Football, mathematics is not theory. It is practice. It is a practical skill set. Nobody can say I go for a football academy and then they write everything on the board. That's it. No. So now
the question I asked earlier on before, I think that time you want to go take water. I asked before, all this topology you have used maybe in the past from what will come in, like if we want to retrieve it from this lab, is there any way we can click to retrieve them, or they are all wiped away?
Some of the labs that I've sent to you, if you download them, it will be on your system.
Okay, okay.
And then like this one, after this, please, after this session, remind me, because immediately after this session, sometimes I have my own activities going on. I'll just fly out. So immediately after the session, I'll send it across to all of us. And then the note, we keep it handy. Anytime we want to do interview, it will become a reference materials, and then we are good. So now, I designed this lab yesterday. So this is what I do. This is our headquarter simulation. We simulate it to be our headquarter location. These are our users. User 1, user 1, user 2, user 3. And then this is internet. And then this router is called edge router. This is edge router. This is internet. This internet is controlled by who? ISP. It may be 1. Like this location now, we have ISP1, ISP2 for what? To avoid single point of failure. In case this link is dropped or blocked for one reason or the other, maybe this router is down, we can have our traffic to go to next available path. And that is our data center. Most of the time, data center may not be in the same location with office. Most of the time, data center may not be in the same location with the office. It may not even be in the headquarters. It may be in a segmented environment. So now, this is our data center. This is our server. Maybe this is our web server. This is our file server. This is our what? Our DNS server. How do we know what is DNS? What is DNS?
Domain network system.
Yeah? Hello? Hello?
Sir?
I said, what is DNS?
Domain name system.
Domain what?
System, domain name system.
Okay, what does it do? Because those are the interview questions. we need to know it the way we know back of our hands. You see, this is a basic question, Steph. The basic question. We have touched base on this in the beginning.
Yeah, I think it does distribute information to the system, to the protocol.
You said what?
I said distribute information.
Okay. Mr. Ken says distribute information.
I think all our information goes there and then send it, return it back to the user.
Nobody got it. And then if we don't get this one, that means we are not trying on our own. DNS is one of the basic questions they have in the interbasic CCNA level. It's like entry level. So they expect us to know it. What it does is this. I've explained it when we started. Anytime we see DNS server, it's a server on its own, DNS. What it does is just that it's a domain name service or domain name system. What it does is this. Anytime we are going to, yesterday, when we are testing one of the servers with HTTP dot the IP, right? IP of the server. I believe we pay attention to that yesterday, right?
Yes.
So now, user will not be able to do this all the time. Suppose we have a DNS server, it will map this IP to the name. Maybe we write it, okay, now if anytime we are going to CNL, cnl.com, CNL has an IP, www.cnl.com. There's an IP assigned to this name. So what DNS does is DNS converts the name, the IP to name. It doesn't do more than that. DNS server, it maps IP address to name. What is readable to the human being or to the end user? It doesn't make sense?
Yes.
So now, let's not do device too much, but let's know that one. When we're discussing other, I believe we have touched base on some of the services, HTTP, HTTPS, DNS, SSH, all that in the beginning. But if we need to visit it, we will revisit them. But during the interview session, some of them will be revisited. Okay, now what I did here is this. I put the headquarter here, the data center, and then this side for internet. The internet is dangerous. So that's why when we're doing what? Firewalling part, we know why we have this router here, this router here, and then why we need to protect our end users from intrusion or from any malicious attack. So having said that, this diagram, there are some of the routers that have IPs, but it's not the IP I'm going to use. Okay, let's do something quickly. We'll do it together. So let's put our IPs, our IP scheme, 192.168.what? Let's use .1.0/24. And then here, we use 192.168.what.2.0/24. And then we can use on this network 192.168.3.0/24. Why I'm doing this is to bring simplicity, for simplicity's sake. 192.168.what we are using .3.4.0/24, and then here 192.168.5.0/24. Let's put here 192.168.6.0/24. 192.168.7.0/24. In production, we may not find it like this, but it's still possible to see something like this in the interior network. I've seen it before, where we have 10.10.1, 10.10.5 for network. So in the east side, we use 192.168.8. Okay, let me do like this. Okay, that's .8.0/24. Okay. Now I've assigned the particular all the interfaces, some of their respective IPs. Now what we did now is this: we just configure. We assign subnets to them. So let's start together from router 1. And then if you look at router 1, okay, if I just put my IP like this, we see that it has some configuration, but we're going to remove them. So we've touched base on how to remove IP before, but we're going to look at it today now again. So the first thing we need to do, we go to the router. This router, there are things we can do, like what? Like putting security there, putting the name of the user, creating user. There's a lot we can do on this router, but I don't want it to be too complex for us, because what we need to pay attention to is how to configure the interfaces, how to configure routers, routing protocols, and how to check them. And then once we understand those concepts, there are a lot of resources online that we can use to move on. And then one thing I said in the beginning is that this industry is very dynamic. In other words, we need to keep learning every day, keep updating ourselves. It's not a static environment because things changes quickly. So now, let's put the command config key. First of all, let's do something. Let's check IP interface brief to see where it's configured. All right. If we see this 3 interface is already configured with fast Ethernet 0 with 10.0.1, 1.1, all of them, I will remove them now. So how do we remove IPs in Cisco router? Either IPs or routing. This is what we do. We do config key, and then we specify the interface. Interface what? F0/1. To remove IP, as we click enter, what we need to do is just to put no space, and then we'll put IP address. Immediately we put no IP, won't be IP there again. And I click enter. Difficult?
No.
Okay. The same thing applies to routing or routing any routing protocol we want to delete. In case we don't want to make use of a particular route no more, what we need to do is just to write no behind the IP address and behind the routing protocol configuration or the commands, and then automatically it will wipe it out. That is for Cisco routers or Cisco devices. Okay, we have removed that one. The next one, okay, we do exit, and then we remove the IP on IP interface F0/0, enter, and then we put no what? No IP address. The same thing on serial number. We have serial keyboard there, interface serial. Interface serial. That's what? X0/0/1, right? And I know IP. Now I click exit or end WR, and there will do show IP interface brief. Okay, this which one? Okay, I did not run the one of /0. I'll run /1. So, but if we look at the first two, is already gone. Let me quickly go back. 15 /0, no IP address, and there was show. We see that everything is gone. So now we will go down to configure our own now based on our own topology. So what we need to do, like I said yesterday, for simplicity's sake and for ease of use, we always make use of what? Notepad. So what we need to do now, we do enable. It's not about having super brain. It's about following the best practice. So enable, we click enter, and then we do what? Config P. Config P, and then we specify the interface. Which is our interface? Interface was F0/0, enter, IP address. What's our IP address? 192.168. What? 1.2.1.254. And the subnet mask is what? 255.255.255.0. We enter, and then no short, and then exit.
I thought it's 198.168, 192.168.2.
No, this is it here. For this interface, is this. There's nothing .2 in this router. Everything here will be .1, .1, and .254. If the traffic is coming from inside, let me make this small. Traffic is coming from inside, it's going to hit this one. If it's going this route, it's going to hit this one. If you're coming this route, it's going to hit this one. Is it clear?
Yes, sir. One more thing. Did you put FA/, you didn't put FA, just put /0. Is that okay?
Yeah, because F means what? Fast Ethernet. So now in Cisco router, F only is used for fast Ethernet, but we must put the number. It will take it. All right. So now let's move on to the what? To the next route to the next interface, which is what? Interface S.
Yes.
S is the serial number.
0/0/.
Serial interface.
Mhm.
Serial interface is no, it has lower what? Lower metrics. Lower metrics I mean is this. You know, we have megabytes. All this bit is measured based on MB. So we have some 1 megabyte, 50 megabytes, 100 MB, and then 1G. 1G, 1 GB. So now 1 GB is faster than 100 MB. 100 MB is faster than 1 MB in terms of what? Downloading. Some of these things we are used to it, but if we don't pay attention to it, it will now be like new thing. No. When we subscribe to like AT&T, they will tell us the number of megabytes we can download per month. Some people say, oh, unlimited. That's a fallacy. There will still be encapsulated, there will be a cap to minimum we can use within a month. Is it making sense? So now some of the links, they have more capacity than them. If you start comparing them, they are more resilient and capable than other. Like fast internet has more capacity than 3-year internet. While G internet, that gigabyte internet, has more capacity than fast internet. But most commonly used today, as we speak, is GEB. Most commonly used as of today is gigabyte interface. They can send, their throughput is very high. So when we are configuring this, we see some of the metrics. So serial cable 0/0/what? 0. Enter. And then what? IP address. So now to make it fast, we'll be copying. Enter. We copy it here. Now what is our IP?
2.1.
2.1. Okay, we click enter. No short. We click enter. And the what? Exit. We click enter. And then we go to the other interface, which is what? Interface what?
F0/1.
F0/1. We click enter. And then the IP address is what?
192.168.
192.3.1. Right? And then we click what? We put no short. Enter. Exit. Now, if we do all this, we have configured what? Interface. But one thing we need to pay attention to here, if you look at here, there's a clock rate. There's a clock here, right? So when we are using this serial cable, we need to calculate the clock rate or configure the clock rate there. So the command is here. I put it here before. All these things, we don't need to memorize them. This is the clock rate. Anytime we are configuring the serial cable, or we are using serial cable, we can use, it is not a default that it must be this is 2 million. No. But in production, you may not see all this. There's another thing we can do, description, Cisco router, but all those one, we don't need it. For notifications, for identification take. The basic thing we need to know to move on to achieve our aims, that's what we're going to touch base on. So I'll copy this clock rate here because this is the side of the command that has the clock rate on the serial cable. I did not put it on the fast Ethernet. It's not on this fast Ethernet, it's on the serial cable because the signal is here. See the clock. And then it's only be configured in one side. If you look at here, it's here, it's here. You can't configure it here because it's not here. So we need to pay attention to it when we are doing our own. So now, what we have done so far is that we have successfully completed the interfaces. So now, the next thing we can do, because we are talking about EIGRP, the next command, and then we should not forget, when we put the next exit, we are going to burst into this interface, which is the configuration mode, global configuration mode. We are going to be here. And then when I was saying about EIGRP just now, I put this command that we need to do what? We enable, we go to from global configuration mode, we put router EIGRP and AS number. And then the command is network address, and then the white mask. In EIGRP or some of the dynamic routing protocol, what we need to pay attention to is this. We advertise our connected subnet. Let me call it again. We advertise our connected subnet in our routing table. You know, when we are doing static, we go here, we go here, we go here, we go here, and we go here, right? Hello?
Yeah, listening to you, sir.
Yes, sir, yes.
So, but in dynamic, if we don't do that, what we do is we put only the subnet we are connected to in our routing table. That is why it's dynamic. So that when we put it here, this router will tell this router that me, I have all this. You tell me what you have. So when they tell themselves what they have, they will not converge, and then they share information of the topology. In other words, if traffic is coming, this guy knows that his neighbor has this. Okay, this is the neighborship. Let's look at your house today. These are our houses. I'm using my environment as an example. Maybe this is my subdivision. This is me here. For example, this is my neighbor. And I have a barbecue stand here. Maybe I love party where I'm doing barbecue. This my neighbor will know that something's smelling. When you look out, you say, my neighbor is doing barbecue because we are close neighbor. This guy now smells strange. Something's smelling. If something's smelling, you now call this neighbor, say, oh, guy, something's smelling. Do you perceive anything? So yes, this guy on the other side is doing something. Maybe he's doing barbecue. It can be goat or fish or whatever. So this guy knows. He put it on his routing table. There's a barbecue going on. There's no case. There's no point calling 911. This is how information is shared. The same thing applies in the networking domain. That is, anything this guy has this guy want to know about it. And then you put it in the routing table. The same thing applies to this. If this C is doing something, A will not know anything about it, for example. But immediately contact B. Hey, guy, what's going on there? I saw a lot of chairs in front of that guy house. What is going on? He said, oh, he's doing one party, or it can be a birthday party. He put it on his routing table. These are the metrics they use to design the topology. The networking concept is designed based on highway and our day-to-day traffic in the neighborhood.
Excuse me.
Okay.
Can you hear me?
I can hear you, sir.
Okay. So what you're saying basically is the A, according to your example, is dynamic, which
Yes.
is the green one. What is that?
Yes, of course. It's dynamic.
Okay, I just want to make sure I understand what you're saying. Basically.
Yes, it's dynamic because immediately A has information from B, is not static again because it has gotten information of C. Suppose now A now walk alone to meet C, that is static. That is static. Okay. You need to meet this one, you need to meet this one its own. That is static. But in the information that this thing comes to meet A on its domain, that is dynamic. As we move on, we understand it more and more. But what we grant it to our mind is we need to get our life set, do on our own, and read more online. Okay, so where do we stop now? So I was explaining something before that the command, okay, I was on the command of, okay, let's go. So the next thing we need to do, we put router, EIGRP. Now, this is where the AS come aboard. We need to put the AS, so we need to do like 100. 100, EIGRP 100. This is our AS, autonomous system. Autonomous system, I've explained that it's a form of way to group connecting routers or network together. And then autonomous system is always in the confine of a company. That is, they are the one managing it. It's a form of identification as well. Okay, we press enter. Now, we said it before that we need to put our network. What our network? Our network is what? We need to put this command, network, and then we specify our connected network. Which are our connected networks? 192.168.1.0 and what? So now we can stop here in EIGRP. If we stop here, the router will use what they call classful pattern. Classful pattern of subnet. I believe we all know what is classful, right? Hello? Hello?
Listen to you, sir.
I believe we know what is classful. Subnet. Okay, class A, class B, class C, this is /8/16/24.
Yes.
At this point, they are classful because they are not subnetting. So if you leave it like this, the router is intelligent to know that this is class C. It's going to put it on what? /24. But what about we put it on /24, but it has been subnetted? Maybe we put 10.0.1.0/24. If you put it like this, without putting the white card mask behind it, this router will put this network in what? In class A. It will now become 10.0.0.1.0 network. In other words, any traffic coming that fall within this class, the router will allow it to pass. It become class 4. But we don't do that. We want it to be classless. That is why it's one of the functionalities of EIGRP as a classless dynamic routing protocol. So now what we need to incorporate here, we need to tell it our what? Our subnets, our white card mask, which is what? Is 0.0.0.1.255. I believe we know how we got it.
Yes.
Okay, we click enter. So now we have 3 routing connected to us. 3 subnets. We have this, we have this. So we need to advertise it. So what I will do, I'll just copy, click enter, paste, and change some of the parameters. I have .2, click enter, paste, and I have what?
.3.
.3. And then I click enter. The next thing I need to do is what? No auto summary.
Excuse me.
Auto summarization. No auto summary. These are the commands we need to pay attention to in doing EIGRP. So this is the only thing we need to do when we are configuring EIGRP. So what I will do now is
when you stop at 192.168.3 when we have more than 3 routers there.
Now somebody has a question.
Can you take the notepad off? Maybe that's how we can see the topology.
Can I do what?
Now see if we can minimize the notepad so we can see the topology. Your notepad.
Okay, give me 1 minute. Post name. This is router 1. Okay. I explained that when we are doing dynamic routing protocol, we advertise our connected subnets only.
Okay, only. Okay.
Is that clear?
Yes.
Okay, perfect. So what we need to do now, we go to the router and then we copy this, all these configurations. We copy it and do what?
Yes.
And paste. And we click enter. Exit. End. And what? WR. As is, there's nothing will form as we speak now, because this router, only this router knows about itself. It doesn't know anything about other router. So once we configure the second router, which is router 2, we're going to see what will happen immediately we send this command. But to check what we have done, show IP interface brief, we see that all these interfaces are up. Show IP protocols. We see that we have a protocol, which is what? This is the distance. I said the distance for EIGRP is what?
0.
No, 2000. 2000.
2,000
No.
what?
2 million.
2 million. 2
2
million.
million. No, I'm sorry. Hold on.
AD value of EIGRP that I said just now. AD.
Is 90.
See it here.
90. Okay.
And I said we're going to talk about external, which is 170, but we don't need to bother ourselves for that now. The default is what? 90, period.
90.
And then now, if we pay attention closely, these are the things we have done. The distribution EIGRP is 100. These are our AS. Automatic network summarization is not effect because we say no auto summarization. This is the routing for networks. Routing for network, we have .1, .2, .3. When we send this, when we configure the next router now, we can now check our neighbors. Okay, let's check if you have a neighbor now. Okay, let's run this command, show IP EIGRP neighbor. No neighbor. Do we see any neighbor here? Because we have not configured the other router. There's no neighborship. And then I said something before. You see all these metrics. Look at them here. EIGRP metrics, weight, K1, K2, K3, K4, K5. They have the value, bandwidth, delay, eligibility, MTU, and so on and so forth. Okay, let's move on quickly. Let's configure the second router, and then we move to the next page. In other words, we are finished with this. We click on second router, which is what? Router 2. Okay, this one will be very fast because I've already explained everything. So what I'll do is this. I'll do enter. This is what? Router 1. Okay. What I'll do now, I will just copy this. And I will go down. I say router 2. To avoid confusion, let's do this bit by bit again. Okay, in router 2, we do enable. And then what? Config P. And what again? So we do host name, which is router 2. We click enter, and what again? Interface. Interface what? Router 2, we have two serial numbers. Okay. We have S0/0/0. We click enter. And the IP address. What is IP address? 192.168. what? .2. .what? .2.
.2. Yeah.
255.255.255.0. We click enter. And what again? No short. Enter. And then we need to move on to the next interface, which is what? Interface. Okay. We write exit. Interface what? Interface.
Interface S0/0
what? /0/1. Click enter. And then what is the IP there? Our IP is what? IP address 192.168. what? Let's see it. That's our .5.
Yeah.
5. What? .2.
2.
255.255. what? 255.0. We click enter, no short, enter, and then what again? Then we have another clock here, clock rate. Clock rate.
2 million.
You can put 2 million, 1, 2, 3, 4, 5, 6. And then enter. What again? Exit. Because we have two interfaces on this side, right? We have
Yes.
only two interfaces.
Yes.
So now we need to go to router, EIGRP 100. This is what I said the other time. If you put another AS here, it will not form neighborship with the other router. We should not forget. Enter, network, and then our subnet is what? 192.168. what?
.2.
.2.0, and then this the wide pass mask
0.0.0.255.
0.0.0.55. We click what? Enter. The same thing applies to the second side. I copy it to save time. Which is what?
5.
5. We click enter, and then what again? No
Short.
No auto summary, auto summarization. So exit and
right.
And then arrow. So once we do this, we copy it and then we paste. Look at this one. It has more network than this one. This one has only 2 connections, right?
Yes, sir.
Okay, so let's copy our router 2 commands. Copy, and then we'll go to the router. And then this router 2, it has some configuration before. Let me see. Enable config T. No. Okay, config T. Config T. Okay. Do show IP interface brief. Okay, you have some configuration before. So what I will do quickly, interface S 0/0 okay +0 no IP and then the other one too +1 no IP and exit. So now I need to paste. So now when I paste it, please let's pay attention to here. You see that we have this dual neighborship. Can we see all this?
Yes.
New adjacency. This dual is what? It is, they call it diffusion. Diffusion update algorithm. This is the algorithm it uses to form convergences with neighbor routers. You know, we mentioned about neighborship. So he has formed neighborship with .1 on this interface. And it is up. And it is called new adjacency. This is their A what? AS. When we are doing OSPF, we talk about the metrics and some algorithm they use to form neighborship. Please, we shouldn't forget that. Okay, now let's test now. You know, in our router 1, we try to do what? You see now it has started doing what? It has started forming adjacency with it, the neighbor. So before we run this command, show neighbors, there was no neighbor. Let's try it again now. Boom. Shows us that it has what? A neighbor on this. And then look at the sequence number. This is uptime, the interface. Any confusion? Any confusion or whatsoever, any doubt? This thing will not come to us if we don't try it on our own. It's not about how I say it, how many times we spend it or spend here. It is how many times we spend on our own to check it on our own. Okay, I've run this command. Show IP neighbors. Show IP, the same thing, show IP neighbors. Okay, if I run this command, we'll see it now. Show IP EIGRP. Copy it. We go to our router 1, paste it. Show IP route EIGRP. You click enter. It shows that we have a route. G denotes EIGRP. In other words, because we have not configured this router 3, there's no route for it. Do we see it on the routing table? No. Now, this is our what? Our AD, which is 90. The other one is just the metrics, calculating on the richness, reachability, and some other factors. When I configure the other side, we now compare it. Okay, let's move on quickly. If you are getting confused anywhere, just let me come back and I will explain and then explain again so that we get it, because it doesn't make any sense if we spend time and then we don't get it. So the next step is this. We're going to go to our router 3, which is this. Router 3, let's go to our notepad, which is this. I'll do what? Router 3, I'll come here. Router 3. Router 3. So I won't waste any time. I'll just copy all this one, modify it. And then if you have any explanation, we do that. Router 3, I'll change the router name, which is 3. And the interface on the router 3 is not X, it is F. F what? F0/1. And our IP is what? .3.2. And our subnet mask is the same. No short. The other interface is what? F0/0. Our interface is what? .4.2. No short. We don't have clock rate there because it's not a serial cable. This is if internet interface. Okay. Router EIGRP 100. And then our network is what? .3. And then what? 4. So we do what? We copy it. And we go to the router. The router too has some configuration before. I need to delete it. Show IP interface brief. Okay, I will delete them quickly. Config T. We should get used to how to delete interface and route. Config T. interface F what? F fast Ethernet 0/0, no IP add. Boom, that's gone. Then I want to /1, boom, no IP add. We do what? End, exit. So now we copy and paste this one. When we paste it, it has formed adjacency with who? With .1, which is our router 1. This is router 3. So we're done with that. Let's move on with the other router, which is what? Let's go to, let's call this one. This is our router 3. Let's call this our own router 4. CLI is up and running. Okay. We go to the notepad. Okay, router 4, R4. I will copy this configuration. Come down here, paste it. Okay, we modify. Okay, just for to see it how it flies. Router 4 has what? It has serial cables. So which is what?
Interface S.
Cable, serial cable X what? S0/0/1. The IP address is what? .5 is 5.1, right? And then the subnet mask is the same thing. And the other one is what?
Interface
S
S0/0.
/0/0.
/1.
No.
No one?
No one.
Subnet mask is what? The IP address is what?
6.1.
.1. Subnet mask is the same thing. Here we have a clock rate. So we put the clock rate.
2 million.
Yeah, clock rate. 1, 2, 3, 4, 5, 6. Okay. And then our router name will be what? Router 4. So our subnet we need to advertise is what? 5 and what? And 6. And then that's it. So we copy it and we move to the router. Okay, the router has some configuration before too. Enable, conf-t, show IP interface brief. Exit. Show IP interface brief. Okay. Two serial cable is up and running with different IP. So let's copy. Let's remove it. Interface S 0/0/0. Enter. No IP add. Enter. The other one 2/1. Enter. No IP add. Enter. Hang. And exit. So we have configured this one. We paste it to be on what? To be our router 4. Okay, let's move on. We have done with router 4. And then we have configured this one. Okay, let's make this our router 5. Okay, let's go to our command. Enter. Router 5. Router 5. So now our router 5 has what? Our router
0
5,
F
our router 5 has
F
F
0
F
slash
0/0.
Mhm.
IP address is what? 4
1 yeah. Dot
4.1.
Mhm.
And then this one, the other interface is what?
F 0 slash 1
F0/1. And then the IP is what?
7
0.1. And then there's nothing like clock rate.
yes.
No short, no short. And then router EIGRP, our AS is 100. So which network are we advertising? .4,
Yeah. And 7
what? And 7. No auto summary and exit. So
copy
copy it. I'll go to router 5. Enable show IP interface brief. Okay, those interfaces are configured already. Config key. Interface F what? F0/0. No IP ADD.
address.
And then the same thing on 1. No IP. End. Exit. So now let me see. Okay. WR. I'll copy it. Okay, this is router 5. 1, 2, 3, 4. Yeah. Okay. Router 5 is done. Okay, let's go to our router 6. Okay, router 6 command is this. Router 6. Then, okay, router 6. Let me bring this to this side so that we can see it. So on our router 6, which is this, we have router what? Interface what? Router 6, the name. The interface is what? The first interface is what? S what? 0/0/0. And then our network is what? 6.2. Since subnet. And then the other interface is what? F0/1. And then the other interface is 7.2. 7.2. Okay. And then we have another interface that is going to inside. So we need to copy this side. And then we paste it here, which is what? F0/0. And then the network is what? 8.254. 8.254 space. And then router EIGRP 100. So we need to advertise .6.7 and then .8. So we copy it. Okay, the router name will be what? Is it the same? Okay, the router name will be router 6. Copy. Go there. Let me check you. Go IP interface brief. Okay, those interfaces are configured. Let me config T. Okay. Interface or F0/0. No IP add. Same interface is what? /1. No. And then the other interface is what? Interface. We have a serial cable there, which is S0/0, S0/0/what? 0. No IP. And exit. So we need to paste it on here. Oh, that means I did not copy everything. Copy. This one will take some time before it will allow us to move on. So now, if you check this our router 1, enable, show IP EIGRP neighbors. See, you have formed neighborship with who? With 2 routers connected with it. It has hold time, uptime. There are some things we need to know quickly now. Hello message will be sent to make sure that particular router is still up and running. ISMP message will be sent across the board. If the hold time for EIGRP is about 5 seconds or so. 5 seconds. So if the hold time exceeds that, and then the hello message is not respond to, the router will be confirmed what? Be assumed dead. And then this routing information will be deleted from the routing table. Okay, let's go back to our configuration. Okay, paste. This one doesn't, I copy it then. I copy the whole thing, but it's showing only one WR. Why? Copy. Okay, let me use the opportunity to configure one of these so that we can test quickly, because time is flying too. Okay, let me change all this IP. 192.168. what? 1.5. Our subnet mask is what? 245.245.245.0. And then our gateway 192.168. what? .1.254. So we try to ping our gateway first to check. Ping 192.168.1.254. Okay, we can reach our gateway. So let's go back to that router. Why is it giving us? Oh, there's a missing point here. Why? Oh, look at here. Okay. From here, it misses it. Because of what? Because of slash what? This slash 0.
Okay.
Okay, I don't know. I made one point there. So let's come from here. Copy. Go back to it. So after we finish all these configurations, we now test, and then that's the end of the day for EIGRP. But the bottom line is we need to try it on our own. And then if you run into any problem, we can look at it together and troubleshoot. It doesn't come just listening alone. And that is how this environment is not only routing. There's so many things we eventually do when we start VPN, when we start doing some configuration, NAT policy, ACL, and all that. It involves, it deserves, or it entails that we need to try it on our own, regardless of where we hear it from, who is involved. Because if you don't do it like that, we won't be able to ask questions. And then the more we ask questions, the more I will be talking, the more I will be using different analogy to present it. But if you don't have any question, I will assume that all is well.
Can you send this notepad to us, sir?
It is involved. I will think if I need to send it, because I don't want us to be lazy.
Yeah, this notepad, sir.
Yeah, that's what I'm saying.
Okay.
I will think if I need to send it, because if I send it, we may end up not doing anything on our own. Some people just copy it and paste. Whereas we need to know how some of the processes works.
No, I don't think this is just because we're not going to paste like that.
Yes, sir?
No, I said we're not going to paste. It's just like if when somebody is needing notepad, in case I do manually and I'm having like issue, I can quickly just go on the notepad and see how something like that, but not to paste.
Okay. Yeah,
me too. I'm not going to paste. I'm going to work on it. Yesterday, I don't know if you have the topology for yesterday. I don't have it yet.
Sorry.
Yesterday topology.
Okay. So now, what we need to do now, we need to check where our route will follow, so that we test EIGRP. And then if you have put this simulation here, I carry one traffic from here, that's the message to this router, and I press play. We'll be seeing that this guy, you see, some of the messages will be flowing now, and it will show us the protocols involved. You see, this is ICMP. But why, who can tell us why this traffic is following here, not here?
I think because there's no route. This is dynamic, so there's no way over there, I guess. There's no route to that. So you follow the other route.
Any other?
Yeah, it choose to follow one side. It's only when the other one is blocked, it will not choose to maybe like, it's only when the one that is following now is blocked, it can follow the other side.
Another thing I want to add to that is efficiency. If this route is more efficient, then the other route is going to follow this place first, or second, I guess. Second statement.
Okay, I will explain that, but let me configure this. This server. Our default gateway is what? For that network is 192.168.8.254. And then the interface is what? interface is what? 192.168.8 dot what? What did I put there? So maybe dot 5, it doesn't matter, or let me put dot 10. Subnet mask is this. Okay, let me try to ping from here. Ping 8 dot what? 8 dot. What did I put in the server?
10.
Okay, let me try to ping that one. Okay. Okay. So now we can ping the server. Let's try if we can do continuous pinging in this. Okay, doesn't take it. Okay. Okay, I want to simulate it. I'm pinging from this. Okay, let me ping it again. Yes. I'm pinging from that route, from the window to the server. Okay, let me uncheck this constant delay. To be able to show those the EIGRP, the routing protocol, router 0, router 3, ICMP, event list, the capturing. Okay. Now, let me do something just to show us quickly. I will try. We can reach the server from our headquarters going to the server. This is one of our server, but what I see is when the traffic is coming, it passes through here. And I ask, why is it passing through here? Why not here? So let's go to the router. So we see that we have these neighbors. Then this is the old time. This is a return. So let's say trace route. Copy. Okay, trace route to where? We trace the route to. Okay, I don't want to use south. Trace route to where? To 8.10. Copy from here. Okay, from here we go to here. Trace route. Okay, can I work here? Okay, let me check if you can work on this interface exit. Trace route. Okay. 192.168.8.10. Put up. All right. So can we see my screen? Hello?
Yes, we
Yes,
can
sir.
see.
Yes.
You see, everything I say though we need to listen to the video back just to have more understanding. I explained difference between fast Ethernet and the what? And SE, that is serial cable. And I said in the beginning that EIGRP uses some metrics like bandwidth, B, delay, D, and what? MTU, and reliability. So now if you look at this, okay, let me do something. Let me blow this thing up. Let me blow it up. If you look at these metrics now, if you look at here, I do a trace route from this router to the server. It now shows that it's going to follow .3, 3.2, 4.1, 7.2 to what?
8.10.
8.10. Let's go back to what? To our lab. So now if you look at our lab, the guy did not follow .2. Why? Who can tell us why? It follows here, 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 and then land here. Why not here, here, here? And then I said it before, that is, if we have two routes to the same destination, EIGRP will select the best paths. One, the best path we call what? We call successor route, S route. The other one we call what? Feasible route. But if there's nothing, no network, no connection to this destination, that one link becomes successor route. All those ones are just terminologies. What we need to pay attention to is this. The route did not follow here because serial cable doesn't have capacity like what? Like fast Ethernet. And the delay from serial cable will be much more than the fast Ethernet. That is one of the reasons it didn't follow this path. It chose to follow the best path, which is .3. And then logically, if you look at it, we see that going through router 2, we assume that it's more faster than going through router 4. But because of the interfaces connection, I intentionally designed this lab to show us how the path is being selected. If you forget everything, we shouldn't forget that the EIGRP will choose the best path based on some metrics, based on the bandwidth and what? And delay. And then if you quickly go somewhere now, if you go back to our router 1, click enter, enable, show IP interface, interface brief, no, show interface WhatsApp. I want to see that particular interface. Interface what? Show IP interface. S
0
0
slash 0 slash
0 slash 0. Okay, let me try this one. Can we all see it, right? Okay, we can see that. Okay, let me blow it a little bit. We can see that it has what? 1005 MTU, which is this. But there are some functionality I expect that is going to display, which is not even display here. But one of the metrics is this. It uses MTU to determine if both of them are the same, it will look for another thing until it get the best. Okay, let's check the other interface, which is what? Fast Ethernet 1/1. F is F0/1. We have the same MTU. Okay, I want to try if I can see some of the other metrics we can use. We can debug the packet, show the IP route, and then, okay, okay, I don't need this one. Okay, let me see the topology. Copy. Okay, to IP. If you look at it, I don't see if, okay. Is it not too tiny for some of us, or is it visible?
It's tiny though.
Okay.
It's a little bit too small. I don't know if you will make it.
Okay, let me do something. I will copy it and we'll blow it up somewhere else. Okay, let me go to my notepad. Paste. Okay, is it better like this? Okay. What I did is this: I run this command, show IP EIGRP topology. EIGRP will show the topology because it has gotten some neighbors. So now look at this. 1.1 is one word, successors. Successors FD, this is the matrix it calculated. And then we have 4.0, one successors, visible distance. Look at the matrix.
Okay.
But when you look at the 2.0 successors, visible distance, look at the matrix. So now which one is it going to follow?
The shorter one.
Yeah, these are the things we need to, these are the algorithms it uses to decide where to send packets. I believe it's clear.
Yes, sir.
Okay, because this one we are going deep dive, they did not even show me up to this level. So we need to read more on our own, and then we need to do lab. There's no other way to learn this technology than to be labbing, and ask questions. So this is where we call it a day for today. All these three servers, I've not configured them, but what will happen to one will happen to all. But if we want to check like we did the other time, we can ping across the board. We have already pinged from the headquarters to the server. Can the server reach the headquarters? We don't ping what? 192.168.what.1 to the what? .5. And then we see that it's reachable. So this is the end of today's session.